Our last unit is focusing on exponentials and logarithms. So our first part, we're going to look at exponential functions. In an exponential function, we have some number raised to our variable, raised to the x, where our a number, our base number, which is the a, is always going to be positive, but not the number 1. X, however, can be any real number. That's what this means. X is an element of the reals. So do not confuse these with things like x squared, for example. That's a quadratic. 2 to the x, that's an exponential. The variable has to be up in the exponent. So we're going to focus on the graphs to start off with here. And basically we have 2 different parent graphs. If your a number is bigger than 1, then your graph is going to be an exponential growth. It's going to be asymptotic to the x-axis and then grow pretty fast once it passes the y-axis. And the important point that we'll have here is that this is hitting at 0, 1. And now the rate of growth, how fast it shoots up, is really just based off of what the a number is. But as long as it's bigger than 1, it's going to exponentially grow from left to right. If your a number is between 0 and 1, so if your base is between 0 and 1, again, remember it has to be bigger than 0, but it can't be 1, then you're going to have an exponential decay or exponential regression, where it's falling from left to right. It still, however, is hitting at 0, 1. But it's just falling. For both of these, their domain is -infinity to infinity, which coincides with the fact that the x can be any real number. The range, however, is limited. Notice that it's only above the x-axis, so that means it's only from 0 to infinity. Terrible infinity there. And notice that they all have a horizontal asymptote of y equals 0, which is the x-axis. So to get a little better feel for how these graphs look with some actual hard numbers, we're going to graph 3 to the x and 1/2 to the x. So I've already picked the x's we're going to plug in. So my f function and my g function. I'm going to go run through my f function first, plugging these in. So the first number would be popping in a -2. So this is 3 to the -2. Remember, a negative exponent means that we're going to take the reciprocal. So we're going to end up with 1/9. We have to flip it, because again, that would be 1/3 to the second. If we put in a -1 for x, that would be 3 to the -1, and we flip it. So 1/3. If we plug in 0, 3 to the 0, well, anything to the 0 power is 1. 3 to the first, 3. 3 to the second, 9. So if I plot these, I'm going to have to scale a little bit on my y-axis here. I can see that I start off with very low numbers. When x is -2, the y is 1/9. Then it moves up a little bit to 1/3. Then it hits 0, 1, 1, 3, 2, all the way up to 9. And I can see that it's going to grow very fast to the right of the y-axis. For letter B, now I'm doing a number between 0 and 1, so 1/2 to the -2. Well, the negative means flip the fraction, take the reciprocal. So this will be 2 over 1 to the second. So that'll give me 4. 1/2 to the -1, I would flip the fraction and get 2. Anything to the 0 power, oops, not a 0, is 1. 1/2 to the first would be a half. 1/2 to the second would be 1/4. So oops, let me get my y-axis here. So -2 up at 4, -1 up at 2, 0, 1, a half, 1/4, and I can see that I am falling. Oops, it does not dip below the axis though. Let's try that again. I am falling from left to right. So it gives us just some more concrete numbers on what I was discussing at the top. Now we're going to look at transforming these functions, putting moves on them. The exact same rules apply that you learned in algebra, probably algebra 1, algebra 2, college algebra, whatever you've taken. The same rules are going to apply. So we're going to do some matching here. The first one is just a generic exponential where the base is bigger than 1. So that's going to be a generic exponential growth. That looks like the green one here, number 4. For letter B, we've got 3 to the x, so think of that as our parent, but now it has a negative out in front. That's going to reflect it over the x-axis, just like it's always done. So that's going to reflect it, and then +1 is going to shift it up 1. So if I imagine taking the parent graph, flipping it over the x-axis, but then pushing it up 1, this would look like graph 1, the red one. For the next one, 4 to the -x. So 4 to the x would have been my parent graph. A negative on the x reflects me over the y-axis. So take the normal parent and flip it over the y-axis. That would look like number 2. For letter D, 1/4 to the x. So now my base is between 0 and 1. So this would be a parent decay. This is actually also graph number 2. And we can see that if we use our rules of exponents, if I take graph of C, 4 to the -x, well, I know that a negative exponent just means take the reciprocal. C and D are really the exact same thing. And for the last one, letter E, so 1/2, so the base is between 0 and 1, so I'm thinking decay. X minus 4, that means shift to the right 4. So this would be a decay that's shifted to the right, so that would be graph 3. So exact same rules apply. On number 3, I have a graph and we want to figure out what is the exponential function that would match this. So really this boils down into figuring out what that base number is. What is that a number? Because I know it's a to the x and I'm given an x here, 3, equals your y, 1/8. So I've got to ask myself, okay, what to the third power is 1/8? Well, that would be a half. So that tells me that my base on this is a half. So my generic function, or not my generic, excuse me, my exponential function would be f of x is 1/2 to the x. Because again, you could test this. If I plugged in 3 to that, I'd have 1/2 to the third. 1/2 to the third is 1/8. You also could express this as let's see, we could do it as 2 to the negative x. That also works. Because if I take 2 raised to the negative 3, because I'd be putting 3 in for x, that would cause the reciprocal and give me 1/8. So really, either one of these is correct. On number 4, A and B, we're going to graph these functions. And really what I'm worried about is what happens to the point 0, 1. Kind of think of that as our point that's moving. So for 4A, and I'm going to graph these in 2 different colors, so I'll graph A in red. X plus 1, that would be a shift to the left 1. So imagine taking the point 0, 1 and shifting it left 1. Since my base is bigger than 1, it's going to be an exponential growth. And so this is just going to look like something like that. Now, it is not asymptotic to the y-axis. It will hit that eventually. But I want just a fairly rough graph here. The domain is still negative infinity to infinity. The range did not change. It's still just like the parent, 0 to infinity. And my horizontal asymptote also did not change. It's still y equals 0. For letter B, we'll do this one in blue. It's 6 to the x, but then plus 1. So again, the point on the parent function is 0, 1. I'm going to move that up 1 to 0, 2. Now, also realize that means that my horizontal asymptote, which was the y-axis, excuse me, the x-axis, is also going to shift up 1. So you don't have to draw the asymptote, but realize that that's going to be my new horizontal asymptote. So this function is going to hug y equals 1 and then shoot up after that. So this has a domain, just like the other one, negative infinity to infinity. This one's range, though, I shifted everything up 1, so its range is 1 to infinity, because the horizontal asymptote is now y equals 1 instead. For number 5, so 10 to the x would be my parent. And again, we want to focus on what would happen to the point 0, 1, and then how would the asymptote shift along with that. So for part A, let's look at what's happening to it. I have a negative on the x. That's going to cause a y reflection. So instead of going rising, it's going to be falling. But it would still be hitting at 0, 1 at this point. But then the -3 is going to shift it down 3. So again, I had a point at 0, 1 that's going to go down 3. That means it's going to hit down here at -2, which means the asymptote, which was, again, on the x-axis, has now also shifted down 3. So that's going to be my asymptote for this graph. And again, that y reflection means it's going to go downhill. So domain, just like it's always been, -infinity to infinity. The range here, the lowest it reaches is -3. Parentheses on it because it's actually an asymptote. To infinity, which gives me a horizontal asymptote of y equals -3. For letter B, let's see what our moves are. This one is going to the right one because I have x minus 1, so that means it's going to go right 1. A negative out in front is going to x reflect. So again, think of the point starting at 0, 1. Don't draw this. It's going to go to the right 1, but then it's going to flip over the x-axis, which means my entire graph is going to flip over the x-axis. So the point is actually hitting 1, -1. And since it's been reflected over the x-axis, it's going to shoot down. And so my domain, still -infinity to infinity. The range here, be careful, this one goes infinitely low and stops at 0. The horizontal asymptote did not switch. It's just that my graph is now below that asymptote instead of above.